Well, hello and welcome to this exercise on vectors. I've got this question from a GCSE higher tier paper 1 and therefore should be suitable for iGCSE higher tier as well and for grade 10 algebra. Now what we got here is a quadrilateral. The quadrilateral is OBYA, which is that one. That's quadrilateral. We're told that the value of vector OA is 3A and the value of vector OB is 6B, and that the value of vector BY is 5A minus B. And further down the line, we also told that the ratio of AX to XB is 1 to 2. Now, it then follows that the ratio of AX to the whole of AB is 1 to 3. So bear that in mind. So for the first part of the question, it says express vector AB in terms of A and B. Okay, right. Now what we need to do then is to say, well, to go from A to B, we need to go from A to A, sorry, from A to O and from O to B. And because we are going against the grain, instead of going from O to A, we go from A to O. We're going from A to O against the grain. So A to O has got to be minus 3A. So the vector AB is AO plus OB, and AO is minus 3A, and OB is plus 6B. If we tidy this up a bit, that will give us that 6B minus 3A. And when we factor it, we'll have 3 into 2B minus A. If that makes sense. And that is what's required here. So vector AB is 3 into 2B minus A there. Moving on. Now, still keeping the first part of the question because we're going to use this again. All right. Now, the second part of the question says we want to prove that vector OX is equal to 2 over 5 vector OY. Okay. Now, to do that, we need to use what we find in the first part of this question. And also, we want to find vector AX using AB and to find vector OX using AX. That's what we call that. Right. AX then. Now, to go from A to X, we know that A to B is 3 into B minus A, which is this one here. And we know that the ratio of AX to XB is 1 to 2. So it then follows that the ratio of AX to XB, sorry, AX to the whole of AB will be 1 to 3. And that's what we got there. So AX is equal to 1/3 of the vector AB there. And we know that AB is 3 into 2B minus A. Hence, AX is going to be 1/3 of 3 into 2B minus A. Now the 3 is cancelled out, so we end up with AX being 2B minus A. That's what we call that. Okay, right. Now we want to find OX in terms of AX. Now OX is from there to there. Now in order to go from O to X, we can go from O to A, and then from A to X. Okay, that's what we're going to do. So now OX is vector OA plus vector AX. OX, vector OA, vector AX. And vector OA we know is 3A because we're going with the grain this time around. And vector AX, as we found out, is 2B minus A. So that's AX there. And simplifying, we have that 2a plus, so vector OX is 2a plus 2b. And when we factorize, we have 2 into a plus b. And that's what we've got there. Okay? Right. Now, we know OX. Now, we need to find OY. Now, how do we find OY? Now, to go to OY, we can go from O to B and from B to Y. So that would then be O to B is 6B and B to Y is 5A minus B. And that's what we go there. When we collect like terms, we end up with vector OY being 5B plus 5A. And when we factorize, we end up with vector OY being 5 into A plus B there. If we now divide OX by OY, we then get 2 into A plus B divided by 5 into A plus B, because this bit here is this bit here is OX, and one at the bottom is OY. The A plus B is cancelled out, so we're now left with OX over OY being 2 over 5. And we then cross multiply, we have this here. So vector OX is equal to 2/5 of vector OY. I hope all that made some sense. Please subscribe, and thank you for watching. Bye bye now. See you again sometime.